All right, so here's the introduction video to our math program. Now, this is the Go Math program. This is Chapter 1, Lesson 1. And some of these earlier videos are going to be a review of things that you've learned before. But I feel it's important to make sure we review those basic facts. So some of the videos will be a little bit longer than the normal videos. My normal videos are between 20 and 25 minutes, which really isn't too much time. It takes me a couple of hours just to make the PowerPoint presentation and then the time to record it. So I'm putting in more time than I'm asking you to spend watching it. But this works really well for those who are struggling to pay attention and focus. And if you find that you're drifting off, you're not paying attention, you can pause the video, rewind. Maybe you didn't get it the first time, and you can re-watch it. You can access these at home. Your parents can access these. So this is a huge benefit for you as my student to have access to the lessons that I am teaching for you. It's for your benefit that I'm doing for these because it's a lot of extra work for me, but I want you to have the best year that you can possibly have and become stronger math students as we go through. So I do a lot of review and making connections for you as we go through the videos. So lesson 1 for Chapter 1, Lesson 1, as I mentioned yesterday, was the basic division with remainders, and then we're also going to be taking our remainders and making them fractions. So the first thing we have to start is really just understanding that there are different ways I can see division problems, and then I'm going to see division problems. This is your basic division problem, which is what you started with all the way back in 3rd grade using the division box. Anytime I set these type of problems up, I still use a division box as a 47-year-old teacher. Other ways I can see it, though, is also in 3rd grade, you learn the division sign in a number sentence. So that works for division. We also have fractions, and hopefully in 4th and 5th grade, you talked about how a fraction simply means division. Yes, it does mean parts of a whole, but there are times that our numerator, our top number, is larger than our denominator, and that just simply means division. The 4th way then is one that we really know as adults, but students haven't had to learn until we start getting into the I-STEP the past couple of years. Now I know I-STEP is done, but you don't know what's to come with the new test that you're going to be taking this year. So I wanted to show you, make sure that we understand that the slash mark after the first number also means division. So you could use it that way. When I look at and understand there are 4 different ways that I can set up these problems, then I have to know the parts of division. And what I mean by parts of division is we have vocabulary terms that go with these math problems anytime we talk about division. It's where they're located in the math problem. So we have our dividend, we have our divisor, and we have our quotient, the 3 parts to the division problem. Now hopefully you can notice that I have different colors on these. I have a red one, and I have a blue one, and I have a purple one, because that indicates the sound that we're focused in on, or the letter we're focused in on these main vocabulary words to tell us their definition. The idea of the EN on dividend makes the sound that the word IN makes. It sounds like N. And since the dividend sounds like N, it is inside my division box. So 528 is my dividend for that problem listed up above. My divisor, it's blue with an O, because the word outside starts with an O. And if it's an outside number, then I know my outside number is my divisor, which is the 32. And therefore my quotient, the U, it just tells me it's up above. My quotient, my answer to the problem, is always listed up above the division box. Once I know those, then I can relate that image into the original ones that we looked at. If I know that my dividend is on the inside, then my divisor is on the outside, and my quotient is the answer, which is up above, then I can locate each of those names throughout here. So when I look at the idea of the dividend, then I know it's the one that's on the inside of the box. Well, when it's written in a sentence form like the top 2, then it's the first number. That's really important because when I go to use my handy-dandy calculator to divide, I have to know which one I type in. Usually when it's in the sentence form, students don't mess up. Even adults have a tendency to mess up on some of the other ones. Okay? So we always type in the 6 divided by the 3 equals, and I know that it's my dividend divided by my divisor. When it comes to the fraction form, then it's my top number that I'm dividing. and I take and type in first in my calculator. So I would put my 6 divided by 3. The one that 6th graders often get confused on, and I've seen adults get confused on, is they want to type from left to right on the division box, and it doesn't work that way. The dividend is on the inside. So I always have to remember that I'm dividing my big number by the number that's on the outside, or I'm dividing the inside by the outside. So that one has to be typed in first. In the same way then with my divisor, it's on the outside. So I know it's being divided by, so the 3 has to be the divisor, the second number. In this number sentence, it's also the second number. To where on the fraction form, it's the bottom number. The top number goes inside the box, the bottom one goes on the outside. And that leaves me with my quotient on each of them as the answer, no matter where the answer line is. Did you know that this top line of the division box is simply your equals mark? Because if that was an equal sign, that's why the answer goes up above. So now we get into the scenario that they've set up for us. And this problem, so this is inside of your regular book. It says when you watch a cartoon, the frames of a film seem to blend together to form a moving image. A cartoon lasting just 92 seconds requires 2,208 frames. So what that means is 2,208 little pictures that have been created to make a 92-second cartoon. How many frames do you see each second when you watch a cartoon? So it is a basic division problem. So when I set it up, they give me my number sentence, and once again, the first number has to be my dividend, has to go inside my division box. And once I have that, then I know I'm going to divide by the second number, so that's going to be my divisor. Now they've already started it, haven't they? So I have the 2,208 divided by 92, and they have a 2 up above. Well, where does that come from? Well, I pick up my handy-dandy calculator and I type 220 divided by 92 equals, and I get 2 point stuff. Well, I don't need the stuff. I'm going to keep that 2. So I keep the 2 and I get rid of everything else. Once I've gotten rid of it, well, then I got to figure out what 2 times 92 is. Why 2 times 92? Well, it means that I'm going to multiply those together. Now, I put a duck up here. Why did I put a duck up here? Well, if you ever watch duck or geese, they got their mama and their papa leading the way, and the babies are following along. Well, in my class, I'm the papa duck, and you're my little ducklings, and you should be following along as I'm teaching. It doesn't matter if you already know it. Just simply follow along, make sure you're filling out your book, and you're focused on listening to what I'm saying. If you're following along, then that means your pencil is in your hand, your book is open, you're on the right problem, and you are taking notes, which we haven't written anything yet, but we're getting ready to. So I've taken my 2 and I've multiplied by 92. Now, with your pencil, the first thing you're going to write down is you're going to cross out this section and this section. The reason being is in this lesson, they basically make the homework twice as long as it should be. They're going to have you estimate every question and then compare your answers from your estimate and your actual answer. And I don't feel like we need to do that. We do estimating later on in the year, so we're just going to hold off on the estimating. So anywhere that it tells you to estimate and write it down, or compare your estimate to the actual answer, we're just going to cross it out, and we're going to do half the work than what they have set up for me. So then I get into dividing and multiplying. So 2 goes into 2, or times 92 is the 184. And then I subtract. Notice the arrow that they bring down the 8 with. I'm going to talk about that here in just a second on the next problem. But once I brought down the 8, now I have 92 going into 368. Well, how many times does it go into 368? Well, I take 368 divided by 92 on my handy-dandy calculator and hit enter, and I see that it goes in 4 even times, because 4 times 92 is 368. So I don't have a remainder on that question. But the answer to the question is, so you see how many frames, that's what the blank is asking, each second when you watch a cartoon, you see 24 frames each second as you're watching a cartoon. That seems almost impossible, but it's actually true. I know some cartoonists and illustrators that they actually work on movies, and she said it really does take that many just to make a short film. So let's look at the next one that we have. We still have these arrows that I said we're going to talk about. So now it says, example 1, we're going to divide 12,749 by 18. Well, the first thing we're going to do is we're going to cross out the estimating. I don't want you to estimate. There's no reason to double the work that we're going to be doing on this assignment. We will do estimating later on. But we're going to go step by step and look at where these numbers are coming from. So when I look at it, I'm dividing 12,749 by 18, and I have to ask, how many times does 18 go into 12? Well, it doesn't. So I have to use 127. I know 18 will go into that, but how many times? I use my handy dandy calculator. I type in 127 divided by 18 equals, and I see it goes in 7-point stuff, right? Get rid of the stuff and write down the 7. Then I'm going to go through my multiplication. Excuse me. And it's multiplication because I have to go from here to get what these numbers are down below. So on my calculator, I just type in 7 times 18, and I get my 126. That leaves me with 1 left over. So now they've brought down this 4. I'm going to encourage you to bring down the 4 and show that arrow, especially for those of us who do not have the best handwriting in the world. And why I do these and type everything else, because my handwriting isn't great. I could write as I'm walking through and teaching it, but it becomes more difficult for you to read, and I don't want you to struggle to understand what we're showing here. But I would encourage you every time to show the arrow. At any time I'm working a division problem, you're going to see me bring down that arrow. So I'm going to have 1 left over, I'm going to bring down the 4. Now, this is a key part to division. If 18 does not go into 14, I can't just leave it blank up above. If something comes down, I have to put something up above. It would completely change my answer if I just skipped it. So if I bring down the 4 and it doesn't work, I have to put a 0 because 18 goes into 14 0 times. Then I bring down the next number. Now, this is an extra step right here. I don't expect you to subtract from 0. That's just extra work that's not necessary to show that you understand what we're doing. And the key is that we understand what we're doing, the process that repeats itself multiple times. So I'm going to bring down my next number, and I have 149. Well, 18 goes into 149 how many times? Well, I take my handy dandy calculator, and I divide 149 divided by 18 equals, and I get 8-point stuff. Once again, get rid of the stuff and keep the 8. Then do the multiplication so you know what's left. 8 times 18 equals what? Well, 8 times 18 is 144, and that means I'm going to subtract and get a remainder of 5. And look, they told me it is a remainder of 5. Now, they say in step 2 what they want you to do is to check your work, and they've given you a couple areas filled in so we can understand what we're doing. So when we check our work, we have to go to our whole number answer, ignoring the remainder for right now. I'm going to take my whole number answer and plug it in. My whole number answer is 708. So I'm going to multiply 708 by 18. Now multiplying by double digits. This is one of those things that I always have a handful, and it's not a large handful, but a small handful of students that have never really figured out what is being asked of them to do. And so every time they multiply by 2, 3, 4, 5 digit numbers, they always end up with wrong answers. I have a simple way of remembering how to do it and showing place values correctly so that it'll always line up correctly. I always start multiplying by the bottom number and the ones position. So I'm going to multiply the top number by 8, and I'm going to move from the right to the left. So I'm going to take 8 times 8, which is 64. So I write down my 4, and I carry my 6, and it's an adding of 6 up at the top. Once I do that, then I have 8, and I'm going to multiply by the 0. Well, 8 times 0 is 0, right? So 0 plus 6 gives me a 6. Then I'm left with 8 times 7. And 8 times 7 is 56. So I have that one done. Now here's where we hold a place value. I always show and say, and you're going to see it multiple times this year, my second number tells me to bring down 1 0. Now if I had a third number that I was multiplying then, I would have my third number tells me to bring down 2 zeros. My fourth number tells me to bring down 3 zeros. And I'm going to do that so I hold my place value and everything lines up the way it's supposed to. If we forget to bring down that 0, then everything that I begin to add ends up with the wrong answer. So I'm going to go to my second number, and I underline it because I'm getting ready to use it, tells me 2, and I circle whatever number of spaces there are behind it. In this case, there's 1 decimal or 1 place value behind it, so I circle it. Well, that circle looks like a 0. So I know that my first number tells me to bring down 1 0, and I'm going to put a 0 in that place. That holds the place value. So then when I multiply by my second number, they're going to end up with answers in the correct spots, which then allows me to line up my addition correctly, and I can get to the right answer. So I'm going to multiply by the 1. Well, 1 times any number is the same number, right? So I could multiply by 8 and get 8, multiply by 0 and get 0, and multiply by 7 and get 7, or just say, well, if I'm multiplying 708 by 1, I'm going to have 708. So now I'm left with addition. Now when I set these up, I do it in a straight row. Math is probably the place where I write the neatest, because if I don't line everything up correctly, I end up with wrong answers. So I try to make it as neat and organized when I set up a math problem. But it allows me just to do straightforward addition. 4 and 0 is 4, 6 and 8 is 14, carry my 1, 6 and 1 is 7, and 7 and 5 is 12. That doesn't give me the answer I started with. Well, I have to remember to go back, and I have a remainder of 5. So I'm going to add, that's what that add the remainder is telling me, so I'm going to add a 5 to it. And when I add a 5 to it, I do indeed get that answer that they're telling me. So I have checked it, and I've proven that 708 with a remainder of 5 is my correct answer to this division problem. Well, let's look at what we're being asked to do next. So as I put up here, however, seldom do we use remainders in 6th grade or higher grades. So when you get here in a couple weeks, actually in about 5 lessons, we stop using remainders. It's just reviewing what you've already learned. And when you get into junior high and high school, we don't use remainders either. Now there are some lessons later on that we'll look at, and we'll realize that the remainder, it's important that there is one, but it's really not going to affect it. So knowing that there's a remainder is important. But what I do with it, instead of just writing an R with the number, that's going to be more important, because we build upon that in 6th grade, 7th grade, 8th grade, and even your high school classes. So let's look how we do it. This says that we're going to write the remainder as a fraction. So that's the way we're going to set it up. It's going to be a mixed number, because there'll be a whole number and a fraction. Okay? And we're going to take 59,990 and divide by 280. Now there's 2 different ways that we're going to do this problem, or can do this problem, and I won't expect you to write down the second way, but I want you to see that there's multiple ways to do math problems. The way that's not allowed is I type it in my calculator and write down the answer. I got to see your steps. And your steps may be a little different than what somebody sitting across from you might be doing, or somebody at the next table might be doing. But if you get to the same answer with logical steps and that you can explain them, that's our goal. You can understand it, you get it, and you can apply it multiple times. So if I cross out the estimating parts because I don't want to do the extra work, I just want to do the work that I need to do to show my comprehension and understanding of the assignment. So I know I'm going to make sure that I'm following along with my teacher, that's me, and I'm writing down the notes that he's asking me to, and that's in your book. That's why I'm showing you the page. I want to start with, will 280 go into 5? No. Will 280 go into 59? Still a no. Will 280 go into 599? Yes. So I use those 3 numbers. Okay? So we'll show you the second way in just a second that I would consider a shortcut, but either way will be successful. We're going to do the way the book has set it up, because that's where all these blanks are going to be filled in. So I have 3 digits, so I know I'm going to have to go in 3 digits here. And if the 3 digits were smaller than the 280, then I would go 4 digits, and so on. So I'm going to take my 599, enter it into my calculator, and I'm going to divide. So dividend entered in first, division, and then I'm divide by the 280, which is the division. I get a 2 in stuff, right? So I drop the stuff, I write down the 2, and then I'm going to multiply, that's how I get this next answer, 2 times the 280. Well, 2 times 280 is 560. Now I can subtract. 9 minus 0 is 9, 9 minus 6 is 3, so I have 39. Now, Once again, I'm not going to make you show the arrows, but I would suggest it, and I always do. Even as a mathematician, I have a math endorsement from college, I still show my arrows. I bring down the next number, which is a 9. So now I have 399 divided by 280. I take it, type it into my handy dandy calculator, divide it by 280 equals, and I get a 1 and stuff. I drop the stuff and I write down the 1. That leaves me with 1 times 280, which is just 280, right? So then I can subtract. 9 minus 0 would be 9, 9 minus 8 is 1, and 3 minus 2 is 1. So I end up with 119 as a remainder. But I still have another number I can bring down. So I show my arrow and I bring down that 0. I make sure everything's lined up. Now that I've dropped down the last one, I know I'm done. And whatever my remainder is, I can do my next step. So I'm going to type in 1,190 divided by my divisor, which is 280, equals, well, it equals 4, because 4 times 280 is 1,120, and that does give me a remainder of 70, so I know I'm on the right track. Well, if I have 240 remainder 70, now what do I do to get a fraction? Well, it's not difficult. I just have to remember a couple steps. First, as I'm doing it, that my remainder is always going to be my numerator of my fraction. So what is left, I'm going to put on top as my numerator. The second step is that my denominator is always my divisor. It's always going to stay the same. It's always going to be the same number. So my divisor is 280, I'm going to put it over 280. But anytime I create a fraction as an answer, I got to reduce it if I possibly can. And in this case, I definitely can. Now I could reduce it by a larger number, but I'm going to take 2 steps which are easier to see. You may not be able to see that 70 goes into 280 evenly, and that's fine. If you do, that's what you can do. Okay? But one of the first things that I saw was that they both end with 0. And if they both end with 0, I can cancel out that 0 on top and that 0 on bottom. What that leaves me with is then 7 over 28. Now, reducing fractions means I divide the numerator and denominator by the same number. And since 7 does go into 28, then I have to show that I'm dividing 7 by 7 and 28 by 7. And if you don't know those off the top of your head, your handy dandy calculator, it's a number sentence, so I would type in the first number divided by the second number. 7 goes into 7 one time, and then on my denominator, 7 goes into 28 4 times. So my remainder is 1/4, and my remainder has to be added to or put with my whole number. So I end up with a mixed number of 214 and 1/4. Now, like I said, I'm going to show you the same problem. I'm going to make it a little bit different. Okay, so there's, to me, is a shortcut. I like to work with the smallest numbers that I can possibly get. And the book didn't set it up this way, and that's why I didn't show it the first way that we worked through it. But this is another way. If you want to write this out on a separate piece of paper over to the side if you have space, then that's fine, just so you can have a reference to look at. The first thing I notice when I set that up is both of these end up with zeros, like I talked about with the remainder before. And if they both end with a 0, I can cross those zeros out and get rid of them. That, instead of having me divide by 280, allows me to only divide by 28, which makes my math a lot easier. So then I work through it. 28 will go into 59. 28 goes into 59 one time, right? So if it goes in, or I said one time, I'm sorry, I need to slow down. It goes into 28 2 times. So when I type it in, 2 times 28, I get a total of 56 point stuff, right? If it goes in 2 times. So when I subtract, I end up with 59 minus 56. And that gives me a remainder of 3. So now I have to ask, well, will 28 go into 3? It won't. So I'm going to bring down that first 9. Will 28 go into 39? It will. If I type it in, 39 divided by 28, I get 1 point stuff. Get rid of the stuff, write down the 1. 1 times 28 is 28, and I subtract, and I get a remainder of 11. 28 won't go into 11, but I got a 9 to bring down, right? So I bring down the next 9, and that's 119. I divide 119 by 28, and I see that it will go into 119 4 times. 4 point stuff, right? Drop the stuff, keep the 4. 4 times 28 is 112. That gives me a remainder of 7. Now, what did we say about the numerator with a fraction? The numerator is always the remainder, right? So my 7 becomes my numerator of my fraction. And then my divisor, which is now 28, becomes my denominator. That takes me back to the same place that I was previously without the zeros. So now I'm going to divide the 7 and the 28 by the 7. 7 goes into 7, 1. 7 goes into 28 4 times. And I end up with the same number that I had before just by doing simpler math with just dividing by 28 instead of 280. So there's more than one way to do the math problem. As long as it's logical, makes sense, and it's repeatable, it's acceptable by your teacher. But you have to show me work and have a correct answer. Each problem that I grade is worth 2 points at least, as long as there's work to show. Some lessons there won't be work to show, but it's only because if we're talking about a prime or composite, it wants a word, which will be the next lesson. Most of the time there'll be work to show and there'll be an answer. Sometimes the questions are going to be worth 3 points because it also has a label. But no matter what, either way that I do that one, it's a 214 and a remainder of 1/4. All right, so this one says to describe 2 ways to check your answers in example 2. So once again, when it comes to these type of things, I only want you to do 1. Okay? Yes, there's 2. There can be 2. You only need to have 1 of them down. So describe a way that you can check your answer to this problem is 214 and 1/4 or 214 remainder 70, the correct answer. Well, one way you could check it is you could multiply the 214 by 180 and then add the 70, which was the remainder, right, to it to get the 59,990. The second way that you would do it is I would multiply 214 by 280 and multiply 280 by 1/4 and then add those together, those 2 products together, to check my answer. So as long as you have one of those written down, it's fine with me. This one's an easier way to check and it's less words to have to write. And if you're not ready to move on though, just pause the video now. That's why this using a video is easy to do, and then replay to move on to these. So my practice question number 1 and 2. The first thing I'm going to do is I'm going to get rid of my estimate. I'm not going to estimate. It's extra work that I don't need to do right now. Then I'm going to find my quotient, and it says to write the remainder, if any, with an R. Okay, so it may have remainder, it may not, and I don't have to worry about fractions at this point. I just need the R to show remainder. So I'm going to set it up, which it's on my paper, and then I'm just going to divide. 29 goes into 98, 3-point stuff times. Drop the stuff, keep the 3. Multiply to figure out what that equals. Well, 3 times 29 is 87. So I subtract. When I subtract, 8 minus 7 is 1, 9 minus 8 is 1, so I have 11. Now I have another number left, so I'm going to bring down the 6. That tells me that I have 29 going into 116. When I type it into my calculator, though, I start with my dividend. So I take 116 divided by 29 equals, and I see that it's 4 and what? Well, it's 4 and nothing. There's no remainder, is there? So I know that I have a 0, and I'm done. So my answer is a whole number on this one, which is 34. Now, that would be worth 2 points, because I've showed all my steps in my work. I got my correct answer, so I got 2 points correct. Now let's say somehow we got off, and you showed work. However, my answer was wrong. If your work at least makes sense, and I can see where you just made a simple calculation, you still get credit for showing me work. So instead of me just counting them both wrong and you getting 0 points out of 2, I still give you that 1 point for showing work, even though your answer may be off by 1 or 2 numbers. I'd have to count that wrong, but you get a point for that one. All right, so that one didn't have a remainder, but I'm telling you this one will as we work through it. So on number 2, I have 3,786 divided by 37. So when I begin, I see that 37 goes into 37 one time. There's not stuff after it though, right? That's okay. 1 times 37 is 37, so I subtract and I get a 0. Now, notice the arrow and I bring down the 8. And I ask, how many times will 37 go into 8? That'd be 0 times, right? It doesn't go into 8. Once again, one of the key things to division is if I bring something down, I have to put something up. So if you listen to what I asked, how many times does 37 go into 8? That answer is indeed 0. If I just said, well, it won't, so I'm going to bring down my next number, it's going to change my answer completely. Once I put up my 0, then I can bring down my next number. I don't have to show -0 and then bring down the 8 again. It's just extra work that I'm not requiring. 37 will go into 86, though. How many times? Well, that goes in 2 stuff times, dropping the stuff, keeping the 2. And 2 times 37 is 74, which then I subtract, and I'm going to get a remainder of 12. So once I have that, I have 102 with a remainder of 12, and I'm just using the R, remainder, so that's what I'm going to write. 102 remainder 12. Now think about this. If you said, well, I brought down the 8 and 37 won't go into it, so I'm going to skip it and just bring down the 6, you would end up with an answer of 12, remainder 12. And there's a big difference if mom's going to pay you $12 for doing chores or $102 for doing chores. You want the 102, right? Not the 12, because that's what you truly owe. So those zeros, even though they don't have independent value, holding place value makes them very important and adds value to the overall number. All right, so now on these, when I look at it, once again, I'm going to eliminate the estimate. Make sure you're following along. Make sure you're filling out your book, because what happens is when you come in and you say, I just don't get this. And I say, okay, bring me your book and show me what you wrote down. If you have nothing written down, then what I say is, okay, go back to your desk, rewind the video, follow along, take your notes, because that's what I'm asking you to do. So just simply follow the directions and you'll do fine. Okay? If you come back to me and you show me where you're messing up and not quite getting it, I might be able to find your steps or be able to walk you through it so you understand it, and we'll work through some extra practice problems. So I cross out the estimate and I read the directions so I know what I'm doing, because if I just put remainders on these, I would end up with 2 wrong answers. This one says write the remainder, if any, as a fractions. Now I do the mixed number answer. I remember that I need to set them up in a division box, not a number sentence. That doesn't help me. So I have to remember that the first number is my dividend, and it's going to go inside my box. And my second number is my divisor. It's going to be on the outside. Now it's lined up where I can divide. Will 63 go into 61? It will not. I don't need a 0 there because it's not holding the place value yet. But 63 will go into 611. So I type in my handy dandy calculator, 611 divided by 63 equals, and I'm going to get 9 and stuff. Drop the stuff and keep the 9. Clear my calculator, and then I type in 9 times 63 equals, so I know what I'm subtracting. What I'm subtracting is 567. So once they're lined up, use your handy dandy calculator again. 611 minus 567 equals, and you're going to get 44. Then I bring down the 4. Once I bring down the 4, now I see that 63 is actually going into 444 that's left. So I type in, once again, correct order, 444 divided by 63 equals, and I'm going to get 7 and stuff. Get rid of the stuff. Keep the 7. 7 times 63 is 441. So I have a remainder of 3. Now once again, when I have my remainder, then I have to know where they go and what part they are. So I have my top number, my numerator, my bottom number, my denominator. My remainder is always my numerator of my fraction. My denominator, my bottom number, is always my divisor of my division problem. So the 63s are going to be carried over here. So what I have is 3 63rds, and I have to ask, can I reduce? Well, if I know my divisibility rules, and divisibility rules are going to be important, I'm going to give you a chart on those tomorrow. But my divisibility rules of 3 says, I add all the digits that make up the number itself. And when I get their sum, I ask if 3 will go into it. So what I'm saying is, if I add 6 and 3 together, what do I get? Well, 6 plus 3 is 9. Will 3 go into 9 evenly? It will. So I know 3 will go into 63, and 3 will go into 3, so I'm going to reduce. I'm going to divide numerator and denominator by the 3. 3 goes into 3 once, and 3 goes into 63 21 times. So my fraction remainder is 1/21st, and I have to put it with my whole number. So I end up with 97 and 1/21, or 1/21st. All right, so practice number 4 gives me 11,050 divided by 28. Once again, I want to set up my division box. My first number is my dividend. It goes inside the box. My second number is my divisor. It goes on the outside of the box. 26 will not go into 11, but it will go into 110. It goes into 110 4 times with stuff left over. So I multiply 4 by 26, and I get rid of that stuff. I get 104. And then when I type that into my handy-dandy calculator, 110 minus 104, I get a remainder of 6. Or you might just see mathematically there's a remainder of 6. Then I'm going to drop down my next number, which is a 5. So 26 will go into 65. 2 point stuff times, get rid of the stuff, keep my 2. And 2 times 26 is 65. Or excuse me, it's 52. So I take that from the 65. That gives me a remainder of 13. I bring down my 0, and I ask, well, 130 divided by 26 is what? 130 divided by 26 equals, and I see that it's 5 times. What's my remainder? I don't have a remainder, do I? So I just have a whole number answer of 425. So as I'm working through these, it's step by step by step. Now, here's a side note, reviewing something you've already learned, but I try to make sure I teach it and make sure you understand it. And this is one of those topics that so many 6th graders get confused with, because so many people have taught them different ways. They talk about mouths, they talk about alligators, they talk about desserts. And so what I'm referring to is the greater than and less than signs. I try to make understanding greater than and less than signs as easy as possible. Okay, no matter what, I'm looking at an arrowhead, right? Because it has a point to it. So I teach it by saying that my arrow will always point to the smallest value that there is. So if my arrow, and when I say my arrow points to, I'm talking about the tips of the arrows, the actual points. Wherever that point is, then on that side is the smallest number. So this one points to the left, so my smallest number is on the left. This one points to the right, so my smallest number is on the right. Understanding greater than or less than signs is going to be vital, because we are going to use these on so many chapters in this year. And you need to know them for higher grades of math also. So if you can just remember it always points to the smallest number, then that'll help you know which way it's asking the question. So this one says I'm going to find the least whole number that can replace the gray box to make the statement true. So what is the statement saying? And it's saying that 110 is less than, I know it's saying less than because the arrow is pointing to the 110, is less than something divided by 47. Now Fact Families talks about, well, there are 3 numbers and I can get 2 division problems and 2 multiplication problems using those 3 numbers. And I need to know, well, what this number would be. Now, the way I set this up, and you may look at it in a different way, and I'm not saying your way is different, is incorrect. The way I start by looking at this is, if I know what that would be if that's an equal sign. If I know a number divided by 47 is actually equal to 110, then I can decide what number is going to be greater than that, because the 110 has to be less. So the fact family, I can't divide by something I don't know what it is, so I know that my opposite is to multiply those together. So if I take 110 and I multiply it by 47, handy dandy calculator, 110 times 47, then I get 5,170. So I know, if I'm talking about equal then, that 5,170 divided by 47 is indeed equal to 110. But I'm not talking about equal then, am I? I'm talking about a number that has to be greater because it says the arrow is pointing to the 110, so the 110 is smaller. So what is my least whole number that is greater than 5,170? Well, my next whole number would be to add a 1 to it, so it becomes greater than and not equal to it. So if I add 1 to it, then my smallest answer would have to be 5,171. Now in question 9, This has some comparisons here, and it has more work that I need to do, doesn't it? It's going to compare, but the answers have to be two answers because it says name two whole numbers. And this one says this gray box has to be less than, because the arrow is pointing to it. I know when I stand there, I whites it out, so I try not to stand there. I apologize. And on the second one, it has to be greater than, because the arrow is pointing to the right, and that answer has to be smaller than. So if I figure out two answers for this one, I can turn around and check them for the second one. So that's what we're going to do. When I look at the first one, I know they're saying that 2 times something is less than, because it's being pointed to, 1,180 divided by 12. Well, what is 1,180 divided by 12? I don't know, so I type it into my handy dandy calculator. 1,800 divided by 12, and I get 150. All right, so if that's equal to 150, I wonder what 2 times something would be equal to 150. Well, if I figure that out and I take 150 divided by 2, that tells me 75. So that would make it equal, right? But I can't make it equal, can I? It says it has to actually be less than. So instead of adding to it, that means I'm going to have to take away, right? I have to make it smaller. So if I take 75 and subtract 1 from it, then I get a smaller number. But it says up there in the directions I need 2. So instead of subtracting 1 from it, I'm just going to now subtract 2 from it. That still gives me a smaller number than the 75, doesn't it? So what is 75 minus 1 and what is 75 minus 2? Well, that's pretty easy, right? 73 and 74. So hypothetically, we're saying that those are our possible answers. Do those fit in and prove correct over there? Well, on the left-hand side where those would fit in, it's saying they're greater than what's on the right-hand side. I don't know what the answer to that division problem is, so I type it into my handy-dandy calculator. 3,744 divided by 52 is 72. Do these two check? Well, 72 is less than, because the arrow points to it, less than 73. That's correct. And 72 is definitely less than 74, so that's correct. So those are my 2 smallest whole numbers that could work. Now, there are multiple answers for both of these if it didn't talk about finding the smallest numbers or the largest numbers that will work. And this says to use the smallest numbers for my answers. So I have specific answers that will only work for those questions. Now you may notice some story problems, and we're always going to have story problems. We're always going to take the concepts we're talking about and apply them into language and trying to figure out how we can work them out. All right, so number 10 says, the 128 employees of company volunteer 12,480 hours per week, or excuse me, in 26 weeks. On average, how many hours do they all volunteer per week? Now, this is where some of my students, even going into the last week of math last year, they would miss a point because they would just stop there. Notice there's a second question that follows. On average then, if I know that first answer, how many hours does each employee volunteer per week? So I have to start at the beginning. I have to take the total number of hours and I have to divide it by the number of weeks that are there to find out what the average per week is. So I'm going to take my 12,480 and I'm going to divide it by 26 weeks. 1,000 or 12,480, type it in my handy calculator, divided by 26 tells me 480 what? That would be 480 hours per week. That's for all of them. The second question then says, well, if that's how many were worked per week and there's 128 employees, on average, how many hours did each employee work? So I have to take my hours per week divided by the number of employees. So 480 divided by 128 is going to give me a total of 4. 4 what? Well, my second answer for each is going to be 4 hours per week. So now let's look how this is graded. I have one question, so I show my work, I have my number 480, and I have my label. That's 3 points. So then I have my second question, I show my work, I have my answer, and I have a label. This question, if I was grading it, is worth 6 points. So being specific and following directions will get you more points and a better grade. Then on number 11, a factory produces 30,480 bolts in 12 hours. If the same number of bolts are produced each hour, how many bolts does the factory produce in 5 hours? Well, it's a division problem. And I have to start figuring out with division how many it makes per 1 hour to, in order to use that answer to find for 5 hours. Because there's no good way to change from 12 to 5. I'm not saying it's impossible to do. Those of you that are higher thinkers in mathematics understand proportions and you would be able to figure that out and set that up. But the easiest way to do it is the way I'm going to teach you to do it. So I need to find out how many it makes per hour. That's where we begin. So I'm going to take the 30,480 and I'm going to divide it by the 12 hours total that number was made in. I enter it in my calculator, I divide, and I see that in every hour it makes 2,540. That's in 1 hour. The question actually asks me, how many does it make in 5 hours? So I'm going to take that number and multiply it by 5 to figure out how many are made in 5 hours. So if I take 2,540 and I multiply it by 5 for the question, then I'm going to see that in 5 hours the company makes 12,700. 12,700 what? Because right now I have work and have an answer, but I'm missing the point. So I have to make sure that I put 12,700 volts, because that's what the 5 hours is equal to. So now you'll notice that I skipped 5, 6, and 7. So those of you who are struggling with this lesson, you're going to bring your book back to me, show me where you have been working. I'll see if I can figure out where you're struggling, if you're making a mistake, or we can just simply work through these 3 problems together until you're comfortable with it. For everyone else then, on your assignment, you're going to be on page 9. You're going to do questions 2 through 12. They always do question 1 for you. So you're only having to do questions 2 through 12. And then on the back, for page 10, you're going to do questions 1 through 6. If it says estimating, cross it out. Don't do the extra work. Okay? So work through it. If you have questions, though, please feel free to ask. But make sure if you didn't follow along that you go back and you watch it and make sure you fill in your book so you understand.